Have you ever guys heard about the word Pascal's principle? Do you know what does it mean? What is the definition of Pascal's principle? Pascal's principle is the rule that when force is applied to a confined fluid, the change in pressure is transmitted equally to all parts of the fluid. So that is the definition of Pascal's principle. Let's look on the diagram so you can understand better. This is the basic hydraulic system. It has two parts, one input and one output. So when we pushed in the input, the output will rise up, and vice versa. So that is the simple explanation on how does hydraulic system works. Let's move on to the detailed part. Input force is applied on the input piston. At the input piston, pressure is produced on the liquid surface. Pressure is transmitted uniformly throughout the hydraulic fluid to the output piston. The same pressure acts on the surface at the output piston. Output force acts on the output piston. So that is actually a more detailed explanation on how does hydraulic system works. Based on what Pascal said, pressure on both input and output must be equal. So we can say P1 is equal to P2. We know that pressure is equal to force over area. So we can say F1 over A1 equal to F2 over A2. So we just got a new formula, which is a Pascal's principle formula. And last one, we can find a multiplying factor using this formula, which is A1 over A2. So in this topic, which is Pascal's principle, we have two formulas, which is Pascal's principle's formula and multiplying factor. Do you know brake system use Pascal's principle? Let me explain to you how does it work. So first of all, we need to do some modification to make it more suitable to become a brake system. So one part should be a brake pedal and the other should become a brake pad. We need to make it longer. So this is the brake system. Oh, and there's the tire. Now the explanation begins. When our feet steps on the brake pedals, pressure will transmitted equally throughout the hydraulic fluid and cause the brake pads to clamp the tire. It also causes the tire to stop moving. Now let's make the diagram bigger. So when our feet steps on the brake pedals, it will cause the brake pads to clamp the tire. At the same time, it will produce a frictional force and cause the tire to stop. So that is the explanation on how does brake system works based on Pascal principle. Now, let's see some notes about modification question related to Pascal principle. So this is the hydraulic brake system. So what if the question asks you to modify this hydraulic brake system so it works more efficiently? So these are some aspects and reasons on how can we modify the hydraulic brake system so it works more efficient. First, I choose oil as type of brake fluid. Why? Because it's incompressible and pressure can be transmitted equally in all directions. Second, I use steel for material of transmission pipe because it is non-corrosive, long-lasting, not easily rust, and strong. Third, it has high spring constant of the spring. So it's easy to return to original shape and can withstand high force. Fourth, it has high ratio of cross-sectional area for wheel piston to master pistons. Why? So it can produce bigger output force and easy to slow down and stop. And lastly, it has high boiling point, so it does not vaporize easily and can withstand high temperature. This is a hydraulic jack. It is also related to Pascal principle. So what if the question asks you on how to modify the hydraulic jack so it works more efficiently? So these are the aspects and reasons on how can we modify the hydraulic jack so it works more efficient. First, I choose big area of slave piston so it can produce large output force. Second, small area of master piston, so small input force is needed to push the small piston. Third, I choose longer handle. Why? Because it's easy to apply force onto the small piston. Fourth, low density of body, so it is light and easy to handle. Fifth, I also choose oil as hydraulic fluid because it is incompressible and pressure can be transmitted equally in all directions. Lastly, release valve between small and main reservoir, so liquid can flow into small reservoir to lower the slave piston down. To end our video, firstly, we would like to thank our beloved mentor, Teacher Najah, for helping us finishing our project and for being the backbone of our team. Thanks for the team for giving the best commitment to accomplish our project. I'm sure if we can do this again in the future, it would be great. So, that's all from us. Thank you.